Okay, Sarai, everyone up there, I promised that I'd do a little show and tell here about how to sample for bulk density. It's something very important, so I want to do that right now. It'll be a one-cut shoot here. I'm not going to make this very fancy here, but I'm in a field down here in 5 Points that I think will be similar to your field up there. So what we're going to use today is we're going to use one of the rings here. I don't know what the diameter here, maybe 3 inches here. Make sure you measure the actual height of this thing, and you calculate the volume of that, because that's what we're going to do. We're going to sample for what's called the bulk density, B-U-L-K density, which is recorded in grams per centimeter cubed there. And the reason this is important is because we want to take some of the soil chemistry data that we'll get, like the amount of carbon as a percentage of the soil weight, and we want to convert that to a volume basis. So the bulk density allows us to do that by a simple calculation. So what you should have a couple of these rings up there. You should have a mallet. It's going to be better to have that big mallet that I gave you there, not this hammer here. You should have a 2x4. You're going to probably have to borrow or get some more 2x4s. I didn't have one today, so I'm just using this. And then you should have some of these putty knives here. Okay, that's what you're going to need. I'm in a field right here that should be similar to the one you're going to have after Israel does the work. What you're going to do there is take the ring, put it on the soil, and then just literally put the wood over it and pound that in until it goes all the way down. And it'll be better if you have a 2x4. The reason you use the wood is so that it's not going to be denting the aluminum ring there, okay? This protects it there. Get it, well, I've already dented it. I can see that already because of the way I'm doing this here. All right. What you do is you pound it in there until it's flush with the soil surface. Whoops, see, this is not very good the way I'm doing this one here. All right. And if you have this loose, consolidated situation like we do here today, you're going to have to use some judgment. When that soil comes up to the top, that's about good right there. Then what you're going to do is carefully, you'll need a shovel too here, is dig around that cylinder so that you can get to the bottom of it. All right? You dig around here. What this is going to be is we're going to try to excavate what's called an undisturbed core. And if I make a mistake or if I don't do it right here, I'll have to just pretend here, but you get the idea here. The technique in these kind of things is very important. You can't hurry this too much. I think you're going to probably need to spend a fair amount of time out there doing this, so don't expect to do this in 2 minutes or something like that. So what you do then is you put your hand over the cylinder to protect the top part, and then you carefully take out that soil until you come to the bottom of the ring here. You can see it down there. Okay, and all this takes time. It's all the techniques, frankly, because we want to get an undisturbed, we don't want to have pounded that in too hard. All right, now what I'm going to try to do here is put the putty knife underneath the cylinder so that I get all that soil in that whole volume there. And again, this just takes trial and error. You'll learn how to do this better depending on what your soil condition is like up there. There is actually some moisture in this soil here. So what I'm going to do now is, okay, now I got my putty knife underneath there, and as close to the bottom of that as I can get, I'm going to break it loose there, all right? My hand on top is protecting the top. My hand on bottom, that's not bad at all, okay? That's very good. I got the whole thing intact, so what I do then is I shave this off until it's flush with the bottom of the ring. All right, now that's about good there. Maybe I got too much off there, but that's okay. All right, now we've got a known volume of soil. What you're going to do then is dump this into a paper bag, all right, and we're going to dry this at 105 degrees centigrade for 24 hours. That's the normal drying for bulk density. I got some flies after me here. All right, so you dump this soil into a paper bag, you dry it for a day or to a constant weight, and then you weigh it. That's all you're going to need to do. You'll get the grams of soil per this volume, and that's the bulk density. This is a very important aspect of your sampling. All right, we need to get this as a baseline indicator for what we have. So you put the soil all in the, and you might have to use that screwdriver because this is hard inside there now, but you would save all of this soil. I'm just being reckless here and not caring here, but that would all go into the bag to weigh there. Now, then, I don't know what depths you're going to be sampling at, but for the OREI's protocol there, but you want to take bulk density at each of the depths that we sample for soil. So that was 0 to 6. What I would do is maybe dig with a shovel then. I wouldn't go in that same exact area there because that's kind of, maybe I compacted it with my hammering there. In fact, I'm pretty sure I did. So what I might want to shovel around in order to get the 6 to 12 inches. I'm going to go right next to that area there. I shovel a nice flat area, and then I do it again, all right? I take my ring, I put my wooden board on it, I start pounding in, and I get the 0 or 6 to 12 inches, or 15 to 30 centimeters. And then you take it out, and you put it in a bag, and you weigh it. It's going to take some digging. You're going to have to dig down. The next one, you're going to have to create a little plateau after you shovel down to get to the 12 to 24. And you might have to take some intermediate depth there, like, you know, in between the 12 to 24. That'll be okay there, all right? And then you'll get 24 to 36. I think in the protocol we decided to go down to 3 feet. So this is going to be a fair amount of work. This is going to take some time, some technique, and some attention to detail here, but I wanted to show you what this is like. Another thing you might see is this. This is called a Madeira Sampler. It actually has the 2 slits on it here, one at the top and one at the bottom, and you do the same thing with an auger. You put your putty knives in here, and then you just cut out the top part and the bottom part, and you weigh the inner part there, the middle part there, the known volume there. So this is just another technique on determining bulk density that I'll show you there. Okay, I think that's all then. Let me know if you have any questions, but I hope this is clear enough for you, okay? Pay attention to the details. It's not a hard thing to do in terms of, you know, how complicated it is, but it's hard in terms of some of the work, and also you can't hurry it. You got to be careful on this. Okay, good luck. We'll see you later.